Hello, my name is Jamal Jawad and I've decided to do my presentation on the object pool design pattern. Now, what is the object pool design pattern? When it is necessary to work with a large number of objects that are particularly expensive to instantate, and each object is only needed for a short period of time, the performance of an entire application may be affected. Now, what the object pool design pattern does is it creates a set of objects that may be reused. When a new object is needed, it is requested from the pool. If a previously prepared object is available, it is returned immediately. If no objects are present in the pool, a new item is created and returned. When the object has been used and is no longer needed, it is returned to the pool, allowing it to be used again in the future without repeating the process. It is important to note that once an object has been used and returned, existing references will become invalid. Intent. The intent of the object pool design pattern is that it reuses and shares objects that are expensive to create. Object pooling can offer a significant performance boost. It is most effective in situations where the cost of initializing a class instance is high and the rate of an instantaneous of a class is high, and the number of instances in use at once is at a low. Motivation. The performance can sometimes be the key issue during the software development. Object creation is a costly step. The object pool pattern offers a mechanism to reuse objects that are expensive to create. Clients of an object pool feel like they're the owners of the service, although the service is sharing among many other clients. Now, the objects that are created and used for short periods of time, large amounts of processing power is wasted on object creation. To fix this problem, it utilizes the performance of the object pool pattern. Here's an example of the UML diagram. The client is pointing to the pooled object, and the pool is pointing to the pooled object. The pooled object class is the type that is expensive or slow to instantate, or that has limited availability, so it is to be held in the object pool. Now, the pool class is the most important class in the object pool design pattern. It controls access to the pooled objects, maintaining a list of available objects and a collection of objects that have already been requested from the pool and are still in use. The pool also ensures the objects that have been released are returned to a suitable state, ready for the next time they are requested. Here's two examples. UML diagrams. Now the client is pointing to the reusable pool and the reusable uses on the left side. And on the right side it has the connection pointing to the connection implementation and to the connection pool. Here's an example where the object pool pattern is similar to an office warehouse. When a new employee is hired, the office manager has to prepare a workspace for him. He figures whether or not if there's spare equipment in the office warehouse. If so, he uses it. If not, he places an order to purchase new equipment from Amazon. In case an employee is fired, his equipment is moved to the warehouse where it can be taken when the new workers are needed. So on the right, it shows a flowchart of how the object pool patterns works in this scenario. You have the create a space for a new hired employee. Now you have two options, yes or no. If yes, it takes the equipment from the warehouse if available and delivers the equipment to the workspace. It shows if no, orders new equipment from the store and deliver to the office. Now if the employee is fired, it takes the equipment back to the warehouse. So the warehouse is acting as the object pool and the store is acting as the new object creation. So here we get that. Here's an example of the code of the UML diagram used for my code. So the object pool here, it has the borrow the object, return the object, the shutdown pool, the create an object class, and initialize class. Now exporting task uses pulls from the object pool, and it just uses a thread number, which uses an integer, and then exporting the task, which is an integer, and runs, which is a void function. Then the exporting task uses the exporting process, and the object pool demo pulls from the exporting task. So we can go here and go to the code. Let's close it. I want a file. Object pool. run as Java application. We can see here, now what this does, it just shows the number of object pools created through different threads. And the pool implementation is based on the concurrent linked queue from the java.intil concurrent package. The concurrent link queue is a thread-safe queue based on linked nodes because the queue follows the FIFO technique, first in, first out. The scheduled executor service starts a special task in a separate thread and observes the minimum and maximum number of objects in the pool periodically in a specified time. When the number of objects is less than the minimum, missing instances will be created. When the number of objects is greater than the maximum, too many instances will be removed. This is sometimes useful for balancing out the memory and consuming objects in the pool. Borrow object gets the next free object from the pool. If the pool doesn't contain any objects, a new object will be created and given to the caller of the method. The return object returns the object back to the pool, and shut down, obviously it states what it does, shuts down the pool. Now when you create a new object, creates a new object, the pool is equal to the new concurrent linked queue, and that's how you that's how you create the new object. Now the exporting process, later on if you wanted to, you could do some calls here to do different tasks of the program. Now when you're running the program in the exporting task, it gets an object from the pool, and you can do and that's basically it. Now the object pool demo creates a pool of objects type of exporting process. The minimum number of special exporting processes instances resides in the pool is equal to 4. And the maximum number of special exporting processes instances resides in the pool, which is equal to 10. Time and seconds for periodically checking of minimum objects / maximum objects conditions is in a separate thread, which is equal to 5. When the number of exporting processes instances is less than the minimum objects, missing instances will be created, like stated before. And when the number of exporting process instances is greater than the maximum objects, too many instances will start to be removed. Invalidation interval is negative. No periodical checking of minimum object conditions in a separate thread takes place. So you have 8 separate threads being run here, and that's it. That's the demo. Thank you.